Hello everyone. In the last video, that is in the lecture 18, we had gone through the calculation, that is calculation of pH of buffer solutions. That is we had calculated the pH of acidic buffer and basic buffer. That is we had calculated the equations for pH of for acidic buffer and basic buffer. In this video we shall calculate the change in pH of buffer solutions, that is when we add acid or base there change in pH of buffer solutions. Okay. So, let us see what is the change in pH of buffer solutions when we add acid or base to acidic or basic buffer, right. So, change in pH of buffer solutions. Okay. Change in pH of buffer solutions. By the definition of a buffer, we came to know that buffer solution which resists any change in pH by the addition of acid or base or on dilution. Then what is then why we calculate the change in pH of buffer solutions? Buffer solution itself has the capacity to resist any change in pH. But why we are calculating the change in pH? Because already I had given the explanation for change when we add acid or base to buffer solutions. What happens that I had given the explanation for when we add acid or base to acidic or basic buffer. What happens? I had given the explanation for that. Okay. Now we shall calculate the change in pH of acidic buffer by the addition of acid or base. Okay. So, change in pH of acidic buffer. What is the equation for pH of a acidic buffer? pH of a acidic buffer is pH is equal to pKa plus log concentration of salt by log concentration of acid. This is the pH of acidic buffer. Okay. So, actually in fact change in pH of buffer solution, actually change in pH buffer solution, the change in pH of a buffer solution is very small in quantity. Okay. So, because that is why we are now, so we are calculating that small change in pH numerically. Okay. So, change in pH of acidic buffer, and the pH of acidic buffer is pH is equal to pKa plus log concentration of salt by log concentration of acid. Okay. So, what happens when we add acid? What happens? We shall see what happens, what would happen when we add strong acid to acidic buffer. So, case 1 is when we add strong acid, to acidic buffer, what happens? What is the change in pH of a acidic buffer? Okay, so already what happens when we add strong acid to acidic buffer? Okay, what happens? Already I had given explanation for this in the lecture 17. You please follow the lecture 17 where I explained all the phenomena that takes place when we add acid to strong acid to the acidic buffer. Okay, so I had already I had given a mnemonic to that, that is that mnemonic is AAA, that is for acidic buffer when we add strong acid, acid concentration increases. What happens? Acid concentration increases. For example, if we add C moles per liter, of strong acid is added, C moles per liter of a strong acid is added, what happens? That C moles per liter strong acid concentration increases and that C moles per liter base concentration or salt concentration decreases. From this mnemonic we can understand that for acidic buffer, if we add strong acid, that leads to the increase in the acid concentration and decrease in the salt concentration. So this equation take the form, so pH is equal to pKa plus log concentration of salt. Okay, what happens? Acid concentration increases, that C moles per liter strong acid concentration, that is C moles per liter amount concentration increases in acid concentration and C moles of liter salt concentration decreases. So concentration of acid So that is the change in pH when we add strong acid to acidic buffer. Okay, and case 2, when we add strong base, to acidic buffer, what would happen? Already I had given explanation for what happens when we add strong base to acidic buffer, that is I had already given a mnemonic, that is what is that mnemonic? ABS. For acidic buffer, strong base is added, salt concentration increases and acid concentration decreases. For example, if we add C moles per liter of strong base is added, then pH is equal to pKa plus log concentration of salt increases by log concentration of acid decreases by that amount. Okay, so C moles per liter of strong base is added. So what is the mnemonic? Salt concentration increases. So C moles per liter concentration of salt increases and C moles per liter of acid concentration decreases. Okay, so this is the equation for change in pH for acidic buffer. Okay, and now we shall calculate change in pH of basic buffer. Okay, so what is the pH of basic buffer? What is the equation? pH is equal to 14 minus pKb minus log concentration of salt by log concentration of base. Let us see what would happen when we add strong base to basic buffer and strong acid to acidic buffer. So, case 1, when we add strong base to basic buffer, when we add strong base to basic buffer, what happens? Already I had given the explanation for that in lecture 17. Okay, you please watch the lecture 17 of my videos, right? So, strong base. So, when we add strong base, what happens? There is a mnemonic for that, B. For basic buffer, when we add strong base, base concentration increases and salt concentration decreases. Okay. So, if we add C moles per liter of strong base is added, what happens? pH is equal to 14 minus pKb minus log concentration of salt. Here the concentration of salt decreases by the amount C moles per liter and the concentration of base increases, concentration of base plus C. So, C moles per liter strong base is added, that C moles amount or that C moles per liter concentration increases, that amount adds to the concentration of base and that amount that amount decreases in the concentration of salt. Okay. So, case 2, when we add strong acid, to the basic buffer, what is the mnemonic here? BAS. Sir, for strong base, strong acid is added, salt concentration increases and base concentration decreases. So, pH, if we add C moles per liter, strong acid is added, pH changes by pH is equal to 14 minus pKb minus log concentration of salt plus C by log concentration of base minus C. Because on addition of strong acid to basic buffer, salt concentration increases, and such amount and that amount of base concentration decreases. Okay. So, these are the equations for change in pH of acidic buffer when we add strong acid. This is the equation. Okay. When we add strong base to acidic buffer, this is the equation for change in pH. When we add strong base to basic buffer, and this is the equation, and if we add a strong acid to basic buffer, this is the equation for change in pH. Okay. Now, okay. Now, we shall learn about buffer capacity. Buffer capacity. Buffer capacity. Buffer capacity. Buffer capacity is defined as a number of moles of acid or base that causes a change in buffer that causes a change in pH of 1 liter buffer solution by 1 unit. Okay, I repeat, buffer capacity is defined as it is a number of moles of acid or base that causes change in pH of 1 liter buffer solution by 1 unit. Okay, usually it is represented with a Greek letter, that is beta. Okay, what is the definition? Change in number of moles of acid by change in pH, change in pH. Okay, so here the N is the number of moles of acid or base that causes a change in pH of 1 liter buffer solution by 1 unit, that is called buffer capacity. Okay, so buffer capacity is the quantitative measure of resistance of buffer to the buffer capacity is a quantitative measure for resistance of buffer solution to acid or base. Okay, I repeat, buffer capacity is the quantitative measure for resistance of buffer solutions to acid or base. Okay, usually we call it as a buffer efficiency, buffer index, buffer value. Okay, there are another names for this buffer index, buffer efficiency, buffer efficiency, buffer value, buffer value. Okay, so let us see the what is the buffer capacity of acidic buffer. Okay, so what is buffer capacity? It is the number of moles of acid or base that causes change in buffer solution, 1 liter buffer solution by 1 unit, So the pH for the change in pH for buffer or acidic buffer is pH is equal to pKa plus log concentration of salt by log concentration of acid. Log concentration of salt by log concentration of acid. Okay, so in this equation we can understand the following equations, that is following what is it called when we from this equation we can understanding the following statements. What is that? For example, in this equation, that is pH is equal to pKa plus log concentration of salt by log concentration of acid. Okay, in this equation, if case 1 is if concentration of salt is equal to concentration of acid is equal to 1, then this equal to 1 and log 1 is 0 and pH is equal to, what happens? pH is equal to pKa. Okay, so if concentration of salt is equal to concentration of acid, then buffer pH of the buffer pH is equal to pKa. In this condition, buffer capacity or buffer efficiency is maximum. In this condition, buffer efficiency is maximum when concentration of salt is equal to concentration of acid. Okay, let us see another case. Case 2. If concentration of salt by concentration of acid is equal to 10, that is it becomes log 10, that is log 10, that is 1, then pH is equal to pKa plus 1, and pH is equal to pKa plus 1. Okay, and case 3 is if concentration of salt by concentration of acid is equal to 1 by 10, 1 by 10 means 10 inverse, and 10 inverse when we substitute 10 inverse minus log 10 that is minus 1, then pH is equal to pKa minus 1, pKa minus 1. So, when the buffer capacity is maximum, when concentration of salt equal to concentration of acid, then buffer capacity or buffer efficiency is maximum, buffer value is maximum, buffer capacity is maximum, buffer efficiency is maximum. Okay. If concentration of salt by concentration of acid is equal to 10, then pH is equal to pKa plus 1. If concentration of salt by concentration of acid is equal to 1 by 10, then pH is equal to pKa minus 1. That is buffer capacity and buffer works efficiently in the range of pKa minus 1 to pKa plus 1. Okay. In this range, buffer efficiency is maximum, that is pKa minus 1 to pKa plus 1. Okay. So, we know the pKa value of acetic acid and ammonium hydroxide. Okay. So, we shall do some problems based on this range. Okay. So, buffer capacity is maximum in this range. Okay. So, buffer capacity is buffer works efficiently in this range, that is pKa minus 1 to pKa plus 1. Beyond this range, buffer efficiency decreases. Okay. So, if we want to buffer the capacity efficiency of a pH buffer is maximum in this range only. Beyond this range, buffer capacity decreases. And one more thing is that buffer capacity is maximum at concentration of salt is equal to concentration of acid, that is pH is equal to pKa, then buffer capacity is maximum. Okay. And buffer works efficiently in this in the range of pKa minus 1 to pKa plus 1. Okay. So, I hope you all understand this buffer change in pH of buffer solutions and buffer capacity. Okay. I shall come up with problems based on the buffer solutions in the next videos. Thank you.